Welcome to my lecture on area computations. One of the most important aspects of land survey is area computation, or the determination of the area of tracts of land. And one of the common methods of calculating the area of a tract of land is by triangles. So for example, we are given a triangle and we label this triangle as A, B, and C. If the height of the triangle, denoted by H, and its base, denoted by B, are known quantities, then the area of the triangle is simply 1/2 the product of the base and the height. Now, supposing that we have another triangle and we label this triangle again as A, B, and C. So for example, this is the base and you have another side, known side C, as well as the angle between them, which is theta. The area of this triangle will be equal to 1/2 the product of the base times the side C multiplied by sine of the included angle theta. Now, C sine theta is none other than the height h of the triangle. So if we are to consider the right triangle AB, and let us call this as B prime, the height is h, which is equal to C times sine of theta. Now, if we are to take sine of theta, that is just the opposite side h all over the hypotenuse C. That is why h is equal to C sine theta. Okay, so that's the second one. Now, another is by using Heron's formula. So let us call this again as triangle A, B, and C. The sides are all known, A, B, and C. The area is equal to the square root of S times S minus A times S minus B times S minus C, where S is called the semi-perimeter, equal to the sum of the sides A, B, and C divided by 2. So these are the three possible cases that may arise for any triangle. Okay. So supposing that we have this hexagonal lot, a six-sided lot. Let us label them as A, B, C, D, E, and F. We can apply the triangle method here by simply dividing the entire tract into three triangles. We can run lines through a specific corner point, say at A, then we draw the diagonal AC, the diagonal AD, and the diagonal AE. So we have just divided this tract into 1, 2, 3, and 4 triangles. So we will be calculating the area of the triangles individually, and to find the total area is simply a matter of adding up areas 1 of triangle 1, 2, 3, and 4. Okay? We now go to the other method of finding the area of a piece of land, which is common among surveyors, and this is called the area by DMD method. Now, the DMD refers to the double meridian distance, and we shall define the double meridian distance of a course as twice the distance of the midpoint of a course from the reference meridian. So in other words, if you are given a course, let us call this as AB, all right, we locate its midpoint and we shall call it as M. Next, say this is our reference meridian, and we project the midpoint M onto our reference meridian. Let us call this as M prime. Now the distance between the midpoint and the reference line is D equal to M prime. So the double meridian distance of line AB is simply 2 times the distance M prime. We now adopt the following statements in computing the DMD of each course in a traverse. First, the DMD of the first course is equal to the departure of the course itself. So supposing that we have this traverse A, B, C, and D, and we have our reference meridian. For line AB, this is the DMD. And that DMD of line AB will be equal to the departure of line AB. Next, the DMD of each of the other succeeding courses is equal to the DMD of the preceding course plus the departure of the preceding course plus the departure of the course itself. So proceeding now to line BC. This is the DMD of line BC. And according to this rule, the DMD of line BC will be equal to the DMD of the preceding line AB plus the departure of the preceding line AB plus the departure of line BC. And we shall be applying the same rule for the other traverse lines CD and DA. So if this is the midpoint of CD, this is the DMD of line CD. Of course, twice the distance. No? The DMD of CD is twice this distance. And the DMD of CD is equal to the DMD of the preceding line BC plus the departure of the preceding line BC plus the departure of the line itself or the course itself, CD. Finally, for line DA, twice this distance will be the DMD of line DA. And the same rule applies. DMD of DA is equal to the DMD of the preceding course CD plus the departure of CD plus the departure of DA. And finally, the third rule is that, as a check, you should find that the DMD of the last course is equal to the negative of the departure of that course, meaning the DMD of the last line, DA, must equal the negative the departure of line DA. So this serves as a check in our computations of the DMDs. We now work on the following problem. The following table gives the adjusted latitudes and departures of a closed traverse. We calculate the area by DMD method. So our traverse is made up of 6 traverse lines, AB, BC, CD, DE, EF, and FA. We have the adjusted latitudes and the adjusted departure. Now, before we start calculating the area, we have to make sure that the sum of the latitudes and the departures are both equal to 0. Otherwise, we need to make some adjustment first before we proceed in calculating the area. The first step is we calculate the DMD of each course. So for line AB, the DMD, according to our rule, is equal to the departure of the line. So that is equal to 47.27. Next, for the DMD of line BC, according to our rule, the DMD of any succeeding traverse line or course will be equal to the DMD of the preceding course, which is AB, plus the departure of the preceding course AB, plus the departure of the line itself, which is BC. So in other words, we're going to add 47.27 DMD of the first course plus the departure of AB, which is also 47.27, plus the departure of BC, which is 609.89. And all these will add up to 703.43. So we tabulate that value, 703.43. For the next line CD, we apply the same rule. It will be equal to the DMD of line BC, which is 703.43, plus the departure of line BC, which is 609.89, plus the departure of line CD, which is 786.78. And that will add up to 2099.10. Next line DE, the DMD of DE is the DMD of CD, 2099.10, plus the departure of CD, 786.78, plus the departure of DE, 218.32, which is equal to 3104.20. For line EF, the DMD of EF will be the DMD of DE, 3104.20, plus the departure of DE, 218.32, plus the departure of EF, negative 1116.62, equaling 2205.90. And finally, for line FA, the departure of FA will be equal to the DMD of EF, 2205.90, plus the departure of EF, negative 1116.62, plus the departure of FA, negative 544.64, and that should give us 544.64. According to the same set of rules we have for DMD, the DMD of the last line must equal the negative of the DMD of the, or rather, the negative of the departure of the last line FA. In other words, we have the correct values for the DMDs of the different courses comprising our traverse. The next step in our calculation is the determination of the double areas. So we already have here the tabulated values of the DMD. The double area for each course is determined by simply multiplying the DMD of the course to its adjusted latitude. So for line AB, the double area for line AB is simply the product of the DMD of line AB multiplied by the adjusted latitude of line AB. That is 47.27 times the adjusted latitude of 490.71, which is equal to 23,195.86. So we tabulate this value, 23,195.86. We shall be doing the same rule. We get the product of the DMD and the adjusted latitude. So for line BC, it will be 412,997.82. For line CD, it is 2099.10 times negative 327.41, which is negative 687,260.86. 66.33. Then for line DE, 3104.20 times negative 1002.76, that is negative 3,112,767.59. For EF, that will be negative 270,597.75. And finally, for line FA, that is positive 204,245.45. Okay? So, the next step is we get the summation of all the double areas. So, we add 23,195.86, 412,997.82, down to 204,245.45, which is equivalent to negative 3,430,192.54. And we know that the area is simply one half of the double area. So we simply have to divide our double area of negative 3,430,192.54 by 2, and then we just take its absolute value, which will give us 1,715,096.27, and this is in square meters. So that gives us the area of the given tract of land. Here is the tabulation of the results of all our computations.